Thank you. Good afternoon. I'm pleased to have the opportunity to share with you how, as a designer, my team developed the design for the SUDS networks in North West Cambridge in response to the project brief and local planning policy relating to the development. I'm a chartered civil engineer. I've joined the project team in 2010. I was the project manager for the infrastructure design team. My team prepared engineering input to the development of the master plan. We prepared reports to support the outline planning application and to discharge conditions post-planning. My team developed the site-wide design for the roads, utilities and drainage across Phase 1 and for many of the development plots within Phase 1. Part of my role also included the coordination of our designs with the university's multidisciplinary project team. The project that we are sharing with you today has been developed through regular consultation with key stakeholders over a period of at least 10 years. We have met with many of those stakeholders. Those listed here have a particular interest in the drainage aspects of the project. The University of Cambridge established the need for the development. Their quality and sustainability panel routinely monitored the development of the design and challenged our team to ensure our designs were of the highest quality and considered the needs of the future within our proposals. Of the multidisciplinary design team involved in the project, the landscape ecology and engineering teams have had the most significant involvement in the development of the SUDS network at the site. As infrastructure engineers, we liaised with the Environment Agency, Cambridgeshire County Council, the City Council, South Cambridgeshire District Council, Cambridge Water and Anglian Water regarding the technical designs for the surface, foul, potable and non-potable water networks at the development. We also liaised with the County Council, City Council and District Council in relation to the coordination of the highway, landscape, ecology and engineering aspects of the designs submitted to them for approval at the various planning stages. I stand before you today as an employee of AECOM, although I initially became involved in this project when Scott Wilson were appointed to provide multidisciplinary engineering support to the university. At the time I joined the project team, AECOM were already providing master planning, sustainability, landscape and town planning support to the university. Of the various engineering roles my team have provided as Scott Wilson, then URS and then AECOM, it is the work we undertook on the infrastructure design which my presentation relates to. I've been asked to comment on how the SUDS design was developed to respond to the project brief and policy background, some of which you've already heard. The university's vision was to create a new urban extension to the built-up area of Cambridge. The development principles relating to landscape and drainage included the creation of a central parkland and wildlife corridor, a new place for the community to enjoy, with good pedestrian and cycle links, and a green landscaped area running alongside the M11 to provide a landscape setting and the opportunity for extensive habitat restoration and enhancement. It was also part of the vision that the development was underpinned by the highest environmental standards, embodying best practice in environmental sustainability. In addition to national policy, there were several local strategies and plans which we had to consider, which Emma's already explained part of. Of particular note, we were required that surface water was designed as a SUDS system to reduce overall runoff volumes leaving the site, to control the rate of flow, and to improve water quality before it joins the Wash Pit Brook, which is the watercourse that flows through the site. The development needed to be built as to be an exemplar of sustainable living, able to accommodate the impacts of climate change. It should incorporate water conservation measures to significantly reduce potable water consumption. And as Emma and Stuart mentioned, we had to achieve BREEAM Excellent and COPA Sustainable Homes Level 5. My presentation will cover several phases of the development of our design, through the development of the master plan to submission of the outline planning application, the preparation of designs and strategies to discharge site-wide pre-commencement conditions, and the preparation of designs to support the reserve matters applications. During these phases, our designs developed in detail, but were linked together through the framework that the drainage strategies provided. I will also go on to talk about the detailed design and our role in the construction process. So, the development of the initial design. The university's brief was for a high-quality landscape. This had to be developed with due consideration for landscape, ecology and engineering. We needed to understand the existing drainage regime and flooding mechanisms. We included an allowance within the master plan for conveyance of surface water and attenuation in open features. We worked with the master planners to orientate blocks to work with topography and consider exceedance flows. We worked with the landscape team to incorporate cascading suds, to provide a treatment train and restrict peak discharge leaving the site, and long-term storage to avoid an increase in the volume of surface water leaving the development. The geology at the site is primarily clay, as shown in brown, with limited areas of gravels and sands, shown in blue, and an area of reworked chalk, shown in green, which was prone to creating solution features. There was limited potential for infiltration, and in due course a site-wide condition was imposed which permitted no infiltration at the site. The area to the east of the ridgeline, which is shown as the crosshatch, was not in the catchment of the Washpit Brook. In this area here, levels fell away from the watercourse. Extending the catchment draining to the Washpit Brook to include this area required significant volumes of attenuation to be included in the master plan, as this area was only permitted to discharge at a rate similar to long-term storage. The Surface Water Management Plan also identified that the northeastern part of the site was within the catchment of the Bin Brook wet spot. Several trees and hedgerows were also to be retained, and we were not permitted to alter site levels in these areas. So whilst our runoff rate was limited to the existing catchment of the Washpit Brook, the increased catchment area enabled a significant resource of rainwater to be generated. We had the opportunity to modify the landscape to reduce flood risk downstream of the development and to drain the area that was part of the wet spot. We had the opportunity to create a high-quality environment for the university, and with our clients' long-term interest in the project, we had the opportunity to challenge traditional engineering solutions and create best practice examples. The university decided in 2005 something, to start a collaborative master planning process to plan for the university's future residential and research requirements. The master plan evolved through engagement with local stakeholders and was updated to address feedback from the Area Action Plan and various other workshops. One of the changes was to introduce landscape threads running through the development into the western edge. These threads would function as SUDS corridors, providing areas for ecological habitats and biodiversity and space for recreation and play. A common theme of the master plans was to include a green corridor along the edge of the western edge, next to the M11. Various constraints informed the development of the western edge proposals. We had a gas main and easement running through the site. We had existing ecology that we needed to protect, which prevented levels from being changed. The Washpit Brook is an award watercourse, and we could not relocate it without affecting its legal status. We needed to retain a maintenance zone along the full length of the watercourse. We had to contain floodwater within the site and could not surcharge under the culverts under the M11. In order to respond to the Area Action Plan and the client's brief, we needed to reduce flood risk downstream and create an amenity space. The proposals therefore included for the creation of a two-stage channel along the alignment of the existing Washpit Brook, which is on the western side of the drawing, and the creation of a new relief channel on the right-hand side, closer to the development, to receive flows from the lagoons and to provide additional storage downstream of a new control structure, which was built towards the top. Bunds were included within the landscaping, these green shapes here, to provide visual and acoustic screening of the M11 for parts of the development, and to accommodate material arising from the development. The illustrative master plan, which accompanied the design access and landscape statement, incorporated swales along the primary streets, so through here, swales along Busgate Street, running down there, swales within Green Fingers, of which Stuart's identified several key ones already through there, ponds for attenuation in the western edge, and landscaping, bunds, and the flood reduction scheme. A minimum 2 stages of treatment were available for runoff from pavement surfaces prior to discharge into the relief channel. Once planning consent was granted, we assisted the discharge of several drainage-related planning conditions by preparing designs, calculations and strategies presenting further detail on the proposals. 2 of these strategies, which are relevant to the benefits achieved through SUDS at North West Cambridge, are the surface water drainage strategy and the potable water supply strategy. The surface water drainage strategy was a comprehensive report which defined the runoff rate from each plot into the 8 drainage networks at the site. The characteristics of each plot were considered: its size, underlying geology and location in relation to the ridgeline, For plots to the east of the ridgeline, their runoff rate was limited to 2 litres per second per hectare, similar to that for long-term storage. The illustrative master plan was reviewed to determine the likely permeable and impermeable areas. Runoff from the impermeable areas was assigned to the drainage networks in order to determine the size of the swells and subsurface pipe and net manhole network. The strategy identified the likely attenuation volumes required on each plot based on an assumed percentage impermeable and which forms of attenuation we considered were likely to be suitable. The strategy also identified the volume of attenuation and long-term storage required in each of the lagoons. This document referred back to the flood risk assessment, but also set the framework for the RMA designs that later followed. The east of England has the lowest rainfall in the country and is classified as semi-arid. The Area Action Plan required that the development incorporates water conservation measures to reduce potable water consumption. In order to meet Code Level 5, we needed to reduce the daily potable use to 80 litres per head per day. This table shows the potential potable and non-potable water uses using the Code's water calculator. It identifies that non-potable water could provide approximately 1/3 of a person's daily use through flushing toilets, use in washing machines, and garden irrigation. The university's team reviewed a series of options to reduce potable water use. They considered grey water recycling, surface water recycling, a combination of the two, in addition to the use of water-saving devices. Consideration was also given to the installation of these facilities to each dwelling, or whether they should be provided based on a group of properties or on a site-wide basis. The university chose to use a site-wide rainwater recycling facility. This image illustrates how the process would operate. Rainfall would discharge from each plot into the surface water network. It would pass through swales and into the net water network before being intercepted, treated, and returned to properties as non-potable. There would also be an incoming potable supply to each property. The foul discharge would then pass through a pumping station and into the strategic distribution network downstream. This process ensured that all properties would be connected to the non-potable water network and would satisfy the credits for Code and BREEAM. This slide outlines the process we went through to determine the storage requirement for rainwater. We reviewed historic data from the Cambridge Botanic Gardens from 2005 to 2011 to determine the potential supply of rainwater. Allowances were made for evapotranspiration and maintaining the greenfield runoff to the Washpit Brook. We reviewed the population by network to determine the potential demand for non-potable water. We were liaising with Cambridge Water about the design of the facility, and they recommended that 30 days storage was incorporated into the proposals. We determined the volume of storage required to maintain a non-potable supply throughout the year to take account for the seasonality of rainfall. The larger of the volume to restock that supply or long-term storage was taken forwards into the strategies. Unlike most developments, infiltration was discouraged at Cambridge, partly due to the geology, but primarily to maximise runoff volume from plots into the network for use within the non-potable network. Swales were lined. Attenuation in the form of blue and brown roofs was permitted, but green roofs were discouraged. The university appointed a series of building architects to develop the designs which would lead to the submission of reserve matters for plots within Phase 1 and 2 landscape architects for the wider landscape and urban realm. We worked alongside more than 10 architects to promote the integration of attenuation within the landscape to develop water-sensitive urban design solutions. Maintenance aspects were considered throughout the selection of drainage features. We ensured the levels were designed to consider exceedance events and coordinated underground drainage with tree pits and root protection zones. This is an example of the primary street running through the development. This corridor is to be adopted by the County Council. The swales within this corridor are therefore the only swales which are limited to receiving runoff from adoptable highway surfaces only. In contrast, on Busgate Street, which is to be retained within the university's ownership, it could receive runoff from the street and the surrounding hard landscaping. Extensive consideration of the corridor was needed to ensure sufficient space was available for the carriageway, pedestrian and cycle facilities, verge, landscaping, trees, swales, parking areas, refuse collection bin facility laybys, and underground utilities. This is an example of one of the green fingers running through the heart of the development, which incorporates pedestrian footbridges linking Lot 5 and Lot 2. It's on a strategic cycle route which links the western edge with the district centre and out to the city centre beyond. It's one of the largest green fingers in Phase 1 and provided online attenuation storage in addition to conveyance and treatment. The swales form part of the surface water network which will be retained in the university's ownership. Maintenance of the green fingers and the pipe drainage networks will therefore be undertaken by the university. SUDS features will be maintained to the requirements and frequencies indicated in the Cambridge Design and Adoption Guide, which the City Council prepared. This image illustrates how the swales, lagoon, non-potable water treatment plant and relief channel are interconnected. Surface water discharges into the lagoon from two strategic green fingers, this one which came from the image before, and this one which runs round to the north of the park and ride. After passing through a reed bed into the main part of the lagoon, surface water is extracted and passed through the treatment facility before being distributed around the site as non-potable water, which is a dotted line this way. Cambridge Water have chosen to design and adopt the treatment plant and to adopt the non-potable water network. Part of the lagoon was deepened in order to provide a permanent retention amenity. These images present cross-sections through the lagoon and bund in the western edge. The top image provides an illustration of the landscaped western edge. From the left-hand side, we have the M11, then we have the existing wash pit brook, which will be upgraded to provide a two-stage channel. We then have a maintenance strip, which runs along the alignment of the gas easement, the new relief channel, the bund, and then the lagoon, and lastly the development to the east. We incorporated into the scheme a complex control to ensure that the discharge from the lagoon to the relief channel, over here, is maintained at greenfield runoff rates with the outfall set above the 1 in 100 flood level in the relief channel. I've attached some examples of SUDS used across Phase 1 to provide parts of the treatment train and to restrict peak discharge from each of the plots. Swales were used both on plot and in the wider Phase 1 landscaping. They were used within the Primary Street and Bus Gate Street road corridors. Controlled surface flooding was used on several plots. The example here is from Lot 3 and shows the areas in blue which were designed to hold water in significant rainfall events. In Lot 2, rills were incorporated into the design. Attenuation was also provided in blue and brown roofs and impermeable pavements across various lots. Whilst attenuation crates were incorporated in some of the designs, they were the least preferred solution of the design team, the university and the City Council. AECOM prepared the detailed landscaping and infrastructure designs for the highway corridors and western edge in Phase 1. The underground network of infrastructure at this development is particularly complex. In addition to the standard utilities which accompany every development, we had a district heating network, a non-potable water network and the university's own communications network to integrate. As Stuart's outlined, we also have our own refuse arrangements with underground bins provided across the site. During the detailed design, we updated the surface water and foul water networks to reflect the latest proposals from the plots. We reviewed the velocities in the swales and reduced the gradients where possible to keep them below 0.3 metres per second. Where this wasn't possible, we introduced weirs, check dams and erosion protection. We also gave consideration to the size of channel drains that would be required to drain large paved areas and incorporated those into the design. In order to determine that the highway corridors would accommodate the swales, pipe drainage, utilities, underground bins and landscaping provisions, we chose to model the various items of infrastructure listed here in 3D. This enabled us to include duct boxes, chambers and manholes associated with this infrastructure. Will it work? Okay, so here's my fly through. So what we're following here is the primary street running through the development. So if I try and pause it, we have one of the key green corridors running on part of the site here which will outfall to the western edge. We also have depressions that we've modelled for the swales, and these are some of the hard standings where we'll have bin locations. We also have the foul network in brown and the surface network in blue. So pausing here, this is one of the key green fingers that I had the illustration of earlier. This is the blue's model to show the representation of the earthworks, but that's the green corridor, and it runs down here to where the treatment plant and facility is located. The incoming potable supply was not at a sufficient pressure, and we actually had to have a booster station, and that was provided at the top of the site, up here, from which we then had a potable water network which did a ring around the site. At the southern end here, we had an infrastructure hub where all the various other utility infrastructure, like the foul pumping station, were gathered together in a series of buildings with a common architectural theme. We supported 8 lots with a provision of structural, mechanical and electrical and infrastructure design support up until tender. We refined the locations for drainage connections from the plots into the site-wide networks. We liaised with our building services colleagues to determine where the incoming supplies should be taken to on the plot boundary and updated the site-wide designs accordingly. This is an image from Lot 5, where the university ran a design trial using BIM. On this plot, we modelled in 3D every rainwater downpipe connection, which is shown in blue, passing under the buildings here, and every soil vent pipe connecting to the foul network, modelled in brown. We also modelled the incoming services to the plot, which included the potable and not potable water network connections. The design team continues to provide support to the university through the construction phase. We prepared the construction environmental management plan and pollution control strategy for the wider development to establish the mitigation measures required to prevent pollution and contaminants reaching the Washpit Brook, the groundwater and the SUDS network. We prepared the design for the haul road and incorporated swales and pollution control lagoons in accordance with these strategies to ensure runoff was managed appropriately. The works were tendered as design and build, and during the construction stage, our role as designers has been to provide a design assurance role to the university, reviewing designs to ensure compliance with the reserve matters and to coordinate any aspects during the construction phase if any deviations from the original design are required. Stuart has already shown you this recent image from site. One of the aspects of the potable water supply strategy was to construct the lagoon at an early stage in order that the lower part could fill up before any water was extracted from it. In response to planning policy and comments from the EA and the City Council, commitments were given that the main surface water drainage infrastructure would be constructed in advance of any discharge being permitted from a plot into the drainage network, that runoff from each plot would be restricted to the rates specified in the drainage strategy during the construction phase, and that the construction of the Washpit Brook relief channel and the main Phase 1 surface water network and retention lagoon will take place as part of the first phase of the works to ensure that pollution control protection and attenuation provision was in place for the whole of the Phase 1 development. This photo shows how the university is honouring those commitments. So what messages can we take away from the project? One solution can have multiple benefits. A constraint such as the Washpit Brook floodplain can be redesigned to provide a series of opportunities. That sustainable and green solutions such as swales and treatment lagoons can be cheaper to build and maintain than mechanical engineering solutions and bring aesthetic benefits and biodiversity with them. That rainwater is a resource that has the potential to become increasingly scarce. It should be looked after and reused wherever possible. We are proud to have been involved in such a landmark project and are sharing some of the best practice designs supported by the university and the City Council with other clients. Stuart's already shown you one image of the Western Edge Lagoon. Here's another one I'd like to show you with, but I don't know if there's any ducks. Can't see any ducks, no.
There's a swan in there somewhere.
This shows part of the landscaped area running alongside the M11, providing a wildlife corridor, pedestrian and cycle links and a landscape setting. A community amenity is being created whilst providing a sustainable resource. At the beginning of my presentation, I mentioned some of the policy relating to the development. Some of the key tasks were to design the surface SUD systems to reduce runoff volumes, to control the rate of flow and improve water quality. To include water conservation measures to reduce potable water consumption. This image shows how the project brief and planning policy will look in 15 years' time, once the planting's established, when those are delivered. Thank you.
Thank you very much. Anybody got any quick points of clarification for Suzanne? Yes, David. Sorry, we'll come back to the other gentleman.
Brian Smith, Yorkshire Water.
Brian.
You made reference on the western edge attenuation to a reed bed. My question is in two parts. The second part will become relevant depending on the answer to the first. Who owns the reed bed?
The university. Thank you.
University.
University.
Okay, so therefore, is there a business rates liability associated with that? Because under the Local Government Finance Act 1988, drainage authorities are exempt, and drainage authorities are classed as local authorities or the Environment Agency. So where there is a level of treatment provided, there may be a business rates liability. So does the university have that liability, and what is the extent of that?
I don't know. It's the answer to your question. There has been mention of it. Sorry. There's been mention of it. There's been mention of it, but I haven't heard anything on this for quite a long time. So it's an interesting question.
Okay, thanks. I'm just trying to understand from a water company perspective and what our liabilities might be with HMRC should we go down the route of providing reed beds and cleaning water.
Well, the water company is providing the water at a commercial rate, so I guess that will have some influence on it.
It's not so much providing the water, it's the level of treatment, and water companies are not exempt under the Local Government Finance Act 1988.
I will take your word for that, I'm afraid.
Okay then.
I'll have to look into it.
Thank you very much.
Unless we know anything about this.
No. Gentleman here, if that's all right.
Sorry, George Warren from Alison. I may have completely missed what you said with regards to green rooms being exempt, or rather discouraged. Is that correct? You said that blue and brown rooms were encouraged and green rooms were discouraged? I just wanted some clarification on that one.
That was in relation to we had a condition to not infiltrate at the site. So what we were trying to promote was harvesting as much water as possible to go into the non-potable supply.
My follow-up to that would be, how's that going to work with your policy?
Well, the policy says green, blue or brown roofs that are required for flat roofs. So the developer does actually have an option. Yeah.